Okay, I'm gonna stop the music in the background here for us. There, because really nobody wants to hear Nickelback at 8:30 in the morning.
Are you sure?
Pretty much nobody wants to hear Nickelback ever. But um, whatever. So anyway, yay! Here we are, a live stream. Uh, and what are we gonna do? Well, I have this project here. I will bring up a little write up I did on it over at D Zone.
Wait, where are you streaming to, David?
Huh?
Where are you streaming to? Twitch?
Yeah.
Okay, go ahead.
Um, that's okay. Nobody's going to be watching anyway, so.
Sounds good. Famous last words.
Right? So, I wrote this little article because I'm working on this project this quarter for my job at Camunda. There's my plug for Camunda, which is a proof of concept. Wow, almost 6,000 reads already. Which is this proof of concept of using IoT and Camunda for automation. Stop with the ads already. So, you can. Are you on the stream now? Can you see my screen?
I can see it.
Yay! Okay, so I've got this. This is the sort of the growth in IoT spending, which is monstrous, and then so I came up with this idea of instrumenting a greenhouse, and I bought all this hardware, these sensors to go outside and sensors to go inside. And then came the question of the greenhouse. And there was really no choices between sort of, $650 and $36.
So, two options, like 36 bucks or hundreds.
Yeah, well, the indoor $141 one, it turned out, was like this special Harry Potter version of an indoor terrarium, and they weren't guaranteed to ship anytime in the next 2 months. So we were kind of, well, maybe not. And we decided we'd go with the smaller option in hopes of seeing if it worked, and if it did, then yay. Otherwise, we'll revisit this. So over here I'm going to walk over here to my lab bench, right? And you can see the camera. Hi there.
Yeah.
So I have this really small greenhouse. Here, I'll bring it over here. This really small, cute greenhouse that we're going to try to use, right? And the only reason that this one is a usable option is that it actually opens, right?
How does it open?
Well, right now it opens manually.
I mean, obviously, but like the top or
just this little. It's got, see this little flap, right? Just this flap, which is actually something that real greenhouses do. They have openable flaps on the top of the greenhouse to either vent hot air out or to suck warm air in or whatever, right?
Are you gonna make it so that it based on moisture?
I am. I'm gonna, and so one of the things that I did was I bought where is it? I have it. I bought a motor to do this with, and I don't see it around here. It's fucking huge. I over provisioned the motor by about 100x. It's a stepper motor that's about this big, and you could probably raise a TV with, and it would be, yeah, and it would be great if I'd gotten the $650 greenhouse to go outside, but for this little one, it's kind of overkill. So I'm not going to be doing that. So that's kind of the overview. So the whole thing is, I have a weather station that's going to go outside, right? And I have too much stuff in my office. My office is chaos. It drives my wife nuts. So I bought this weather station. It's in a box. It's a nice little box. It's got an anemometer so you can tell the wind speed, and a vane so you can tell wind direction. And it's got a rain gauge so you can tell how much it's rained.
Okay.
Right? And then for outside, I'm also going to add a CO2 sensor and a temperature sensor and a pressure sensor. So we know basically all of the environmental conditions. Oh, and a particulate sensor. And that's good for pollution, but it's also really good for telling the pollen count, right?
Oh, nice.
Because pollen falls in those things. So if you're running a greenhouse and you don't want cross pollination with outside stuff, and the pollen count is very high, you want to keep your little flap closed. So luckily I have some smaller motors, so I will be able to motorize this with something other than the giant stepper motor, which would barely even fit inside this little greenhouse. So,
Do you have like this huge motor in the greenhouse and this little bitty basil plant in the corner that's like
so I don't. Can you see this? This is the greenhouse, and it's got all this stuff in it, and that's like all the sensors and stuff. So
Are those all the sensors that have to be on the inside or the outside?
almost all of these have to be on the inside. So I've also got a to go outside along with that weather station and the outside monitoring. I've got a soil moisture sensor, right? So I can tell basically, yeah, it's rained a lot in the last week, but also there's a lot of moisture in the soil, and all of these things can come into play when you're looking at how to manage the inside of your greenhouse, right? So inside the greenhouse, we will also have a CO2 sensor and some soil moisture sensors so we can tell when our plants are watered or not. We will have pressure, humidity, and temperature, right? So we can map all of that. And the other thing that we have is, and this, I just realized that I had this thing not long ago because it came in another kit that I never used, is this little thing, which is a pump that you can put down in a thing of water, and you can turn it on and off with a sensor, and it will pump water out the tube. So then we can actually automate watering inside the greenhouse as well.
So I have that same pump, or maybe not the same pump, but I have a pump and tube from
Adafruit?
Argon.
Oh, okay.
Yeah, I was supposed to. I'll be right back.
Okay.
This is the whole reason why I was so excited about coming online with you today. It's because, I was going to do this Zen workshop, and then the night of the workshop, I had a family emergency, so I couldn't join. But there's my little pump.
Yeah, that's the same pump. Yours is just black and mine is white.
Yeah.
Yeah.
And also the other thing I was going to ask you, are you using a Raspberry Pi or Arduino or?
I'm not currently planning to use any Raspberry Pi, although so I'm still sort of figuring out how I'm going to integrate to a back end, right?
Mm-hmm.
So the whole thing I'm moving towards is business process management using Camunda to orchestrate all of this, right?
Okay.
So writing a business process so that I can orchestrate when the door opens, when the pump runs, all this kind of stuff, right? And so I will be piping all of this data. All the sensors are going to run on basically Arduinos. I use these. I happen to have one here sitting on my desk. It's an ESP32 from Adafruit. They're super easy to program. They're super small. And this one is actually running a CO2 sensor that I typically sits out on my front porch and runs full time on my front porch. And so I can do a continuous monitoring. Here, I'll show you actually what I'm. This is actually, I believe, where's my pointer? There it is. Yeah, this is live data from, this says outside humidity, outside temperature, and outside CO2, but it's actually this one on my desk because it stopped working and I had to bring it inside and take it apart and figure out. So that should cause it to spike. I don't know if I have to reload this or not. I may have to reload this. It's been sitting for a minute.
I love it. Is the CO2 monitor working? Hello?
Yeah. Is this thing on? It may not be. I may have to, you know.
No, look, what is that little spiky in the blue?
This one?
Upper left-hand corner.
That one?
Is that the one?
No.
That's the actual one?
No. That's okay. Because I also have,
Sensor. It's like,
way back over here, I have my old version of the CO2 sensor. And there's a whole, this is a totally different CO2 sensor. Oh, looks like it's gotten very hot and tried to melt through the box. Right, so this is a totally different CO2 sensor. It's really expensive and it's large and it takes a lot of power. And if you plug it in and try to run it off an Arduino, within about 30 seconds, you will absolutely cook the voltage regulator. It sucks too much power and the voltage regulator just goes, nope. So if I breathe on that one, that'll be the bottom row where it says K30. That'll be the bottom one. It should spike. Let's make it update faster. So anyway, some of the stuff that I can do with this is, and I've already written the calculations to be able to do this. There's some stuff that really matters for greenhouses, like vapor pressure differential, right? So what's the vapor pressure differential between the plants and the outside? The humidity and the temperature play into that, right? Is the plant going to be losing moisture to the air or not? That matters a lot in a greenhouse. And so I've actually got some, I wonder if they're here. I have a, this is terribly cluttered. No, it's not running. Yeah, I have to update a bunch of libraries. Let's see if it's running anywhere else. Okay, so this is one that is running. This is the this is an ideal gas law computation. You can see the spike in CO2 that I just did when I breathed on it, right? And this uses temperature and pressure to compensate for the CO2 concentration, because as the pressure goes up, you know, gas gets squeezed, right? As the temperature goes up, gas expands. And so you want to compensate for those things when you're measuring the gas. So this calculation does that. This one right here is the heat index, right? Which, if you're in the South where I am, all summer long, they tell you about the heat index. You know, it's 95 degrees, but it feels like 140. And that's because of the temperature and the humidity, and it's you would think it's a really simple thing to do, and the calculation for it is absolutely unholy. It took me a long time to get that figured out, and I don't think I have. No, there's maybe a different one has the vapor pressure differential running on it. It might be this one. No. No. Yes. Here's the vapor pressure deficit and the dew point and the air density. And I've again, the libraries for those, I have to redo the libraries. And then it will calculate that vapor pressure deficit, which is whether or not the plant will be losing moisture or not, right? And the dew point, which is also really important in a greenhouse, is when does the condensation in the air when does the moisture in the air start to condense out? And that means it lands on leaves and things, and then you can start to get things like mold and mildew and fungus and all kinds of bad things, right? So all of this is going to go into, do we water? Do we spray? Do we open the little door with the ginormous motor? Or, how do we manage all this, right? Yes. So, what I thought we would do today is there's a whole lot that needs to happen in order to put this together, right? So I've got soil moisture sensors, one for outdoors and two for indoors, but I'm not sure I can fit two in this little one, so we may only use one because I may only have room for one plant. I've got two CO2 sensors, so we'll need to put one of those together for the outside sensor and one for the inside sensor. We're not going to do all of this today by any stretch of the imagination because there's way too much to do. I got this cool Raspberry Pi fan, because the other thing that I was going to do with this little hinged opening is not only can you open the opening, but do you run the fan or not, right? Do you want to move air in or out, or do you just want to let it vent on its own? So we have a fan that we can run. Then I've got a whole stack of those little ESP32, which I'll run with Arduino, right? So that'll probably be a second coding session when we actually write code for it. For the outside stuff, I have a ginormous battery, and over there I have a solar panel so that all the outside sensor can run solar, and I don't have to worry about running a power cord out there and causing any trouble with that. Okay, so and then in the spirit of over provisioning the motor, I completely over provisioned the motor board for driving stepper motors. So this will drive like 4 of those ginormous motors when I only have one, and I only need one small one. Because over provision. Well, so I was, I had to buy all this stuff before we actually decided on the greenhouse, and so supply chain, and so I whatever. Luckily, I have that cabinet. This cabinet is like full. It's a tool cabinet full of motors and sensor boards and blah, 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 blah. I got like thousands of all of it. I've got probably $20,000 worth of crap in there. So I don't know if you'll be able to see this. This drawer, that's all like Raspberry Pis and other sensor, like Raspberry Pi Zeros and an Up2 kit and this whole Arduino starter kit and all kinds of it's like just ridiculous. So anyway, back to what we're doing today. Oh, I got this to go outside too because this is just super cool. This is a lightning detector.
Oh.
So it will tell you when there's lightning and how far away it is.
Oh, that's cool.
I know, right? So the all the connections to the weather station come with basically telephone jack wires, and I have to have some way to connect those to the ESP32. So I got these little breakout boards from SparkFun to do that, right? So what I thought we'd do is assemble those, and see if we can't at least assemble the parts to the weather station, and then I can go mount the weather station outside at some point, maybe this weekend, and we can start to get data from that. Right, so this is this really cool weather station. And it comes with even like a pipe and some zip ties to mount it. And I ordered this from SparkFun too. I'm like I was actually reading the SparkFun origin story, and I'm like one of the OG customers from there because I've been ordering from there since like 2005. So, all of the sensors, right? This one comes with basically a telephone cord attached to it. And so does this one. And here's the rain gauge. It also has basically the same thing, right? So now I have to build a board that can take those inputs. So that's what we're going to do today. And don't feel bad at home, kids, if you don't have a soldering iron like mine. I have about a $1,500 soldering iron that I actually stole off of eBay for like $400 15 years ago. And if you can ever find a Metcal soldering iron on eBay for anything less than $500, buy all of them you can find, because they are freaking awesome soldering irons. So we're going to take these two little boards and we're going to put RJ11 jacks on each one. And then we're going to take that and we're going to wire it up to one of these ESP32 boards, right? And if we have time, we're going to add a CO2 sensor. And I'll have to find my pressure and humidity sensors and all that. We're going to add all that in. Because we also have, where is my, hey, buddy, can you go to rest? We're live online here. I do. This is, here he is back here. Can you see him?
Yeah.
This is the great Virgolio. And he's lost his toy under his bed. We had a tragedy this morning wherein he had rolled his ball up under the big cabinet here, and I wouldn't get it for him because he does it every day. And I'm tired of crawling, getting up from my desk and crawling under the cabinet just to find his ball, which he will then play with for a minute and then roll up under the cabinet again and whine about. And I'm like, I'm not doing it. So there's a video on my Twitter feed of poor Bruno having an issue and complaining about it at length because his ball was under the cabinet. So anyway, back to this. There's one more board I have to find. Here it is. This is a solar charging board. So this will connect to this battery and that solar panel and this ESP32, so that all the sensors get powered and can run off of the battery and the solar panel. Right? There's no way we're going to get to all of this today, but we're going to give it the old college try. Right? So let's get. Oh, I left my soldering iron on. So you should be able to see pretty clearly with the solder cam. See where I'm soldering?
Yeah.
Okay. So
Yes.
I'll show you my whole setup here. I have my soldering iron, the station for it, and then the wand. I have a benchtop power supply so that I can actually power stuff off the bench rather than having to plug it into USB, which is kind of handy because often I don't want to, I want to just power one thing. I want to just power up, like that pump. I'm like, how does this pump? Yesterday, I was sitting, when I found the pump, I was sitting there and I was like, well, I wonder how this pump, what this pump is actually water. And I looked and it's got a red lead and a black lead, right? So I came over here and I kicked on my power supply and I clipped the red lead to the red lead, and where's my black lead to the black lead, and I'm feeding it 5 volts, and I can feel air coming out of the end of the tube. I'm like, oh, it's a pump. It's really easy. All you have to do is feed it 5 volts and it works, right? So I can test stuff like that. I'm a total freaking nerd. I'm not a hardware engineer. I have never been a hardware engineer. I have never trained as a hardware engineer. I'm a total hardware nerd. I love this stuff. I like putting this stuff together. It's like, it makes my day. And being not a hardware engineer and never trained as a hardware engineer, I blow a lot of stuff up. So there's lots of blue smoke escaping from things, and that's the end of them. Actually, that's one of the reasons that normally what I prototype with is, where is one? I know I have them lying around everywhere. I normally prototype with these little guys. This is called a Wemos D1. It runs the ESP 8266 processor, and you can order these in bulk from China for about $1.50 a piece, right? They're not great for running long-term projects. They tend to be flaky. You know, some of them, the Wi-Fi doesn't work quite right or whatever. They have Wi-Fi and Bluetooth, so they're super handy to have around. But the nice thing is, if the blue smoke gets out of this one, it's like, yep, you just bin it and grab another one, right? Because it's only $1.50, right? So I can screw up a circuit on one of these and not have to worry. These ESP 32 boards from either Adafruit or SparkFun are something like $20 a piece. So when the blue smoke gets out of one of these, it's $20, and when the blue smoke gets out of one of these, it's what, $1.50. So I'm gonna change my camera angle a little bit so that I can. Can you see me still? Yes. Okay. So soldering iron is on, and we are going to start with this little RJ11 breakout board. So we need an RJ11 jack. This is just some fairly straightforward, though I won't say easy, soldering. So it comes with the 6 pins at the bottom, and what do you know, there's 6 pins that go right there. And we take those 6 pins and we line them up to those 6 pins, and the little, that nice little bit locks in there. And now we have to solder it. And I have this handy little thing, this with all these arms and a magnifying glass, because I'm old and I can't see small things. And I only have 2 hands, and it takes at least one to hold the soldering iron.
I need that.
Yeah, I can send you a link that's on Amazon. It was only like $20, and it's got this nice lighted magnifier, and and then it's got 3 other hands to hold stuff, and you can position it exactly where you want it and hold it there, and then all you have to do is hit it with the soldering iron. So, hit it with the soldering iron.
Yep.
Here's my trick for soldering. Took me a long time to learn this trick. Can you see up close here?
Yeah, I can see the wire.
Right? Can you see the end of the soldering iron?
Yeah.
So I actually put it on the, there's a little copper ring around the hole that things go through, right, on through hole. And then there's the wire coming out. So I actually put my soldering iron right there where the wire and the copper ring come together, and I touch the the solder wire to it. So I'm not putting a ball of solder. When the ring is hot and the wire is hot, the solder melts and flows down into the hole, right? And you get a really nice solid solder joint that way. And there's not a big ball of solder.
Do you have to do this?
What, solder these in?
Mm-hmm.
Yeah. So the little plastic clip will keep the jack from falling out, but it won't make a really solid mechanical electrical connection here, right? So the solder makes sure that that connection is 100% around the post and around the part of the board, so that the little wires in here that come down and go through here and come out here are 100% connected. And there won't be any, if it's not 100% connected and something wiggles, then the connection may come loose and you'll get weird stuff and you'll start to wonder, am I crazy because the signal's not right? And no, the signal's not right because I didn't actually solder it, right? So now I actually have to break this board in half. This is actually a two size board. It's two boards joined together. But it's scored so I can just snap it. Okay, it's designed to do that. Don't do that with just any board.
Okay.
It's actually made for that.
Okay.
So now we have one complete jack, right? And when we want to connect it to a board, so these RJ45 connectors, if you've ever taken a phone cable apart, you'll see that they have a yellow, a green, a red, and a blue wire in them, right? So this just takes them and breaks them out to yellow, green, red, and blue so that I can solder wires into those and I know which wire comes from which part of the phone cable and I know where it goes, right? It's way easier than, trying to cut the connector off the end of that RJ45 and find the, that's foolishness. So I will now do another one. Bruno, I'm sorry about your ball, buddy, but I am not crawling under there today. It's really a tragedy. This is a tragedy that unfolds like 4 or 5 times a day. And I'm just not, you can hear him whining. I'm just not having it today. I'm not having it.
I can hear him.
He will begin to talk much more forcefully fairly soon. We will have a whole conversation going here where Bruno is telling me that his ball is under there and he can't get it, and it's. Well, yeah, he just rolled it under there while we're talking about it. Oh no, it's not. It's right here. Hey, buddy, it's right here. You didn't roll it under there. There might be some other toy under there that he shoved under there, because this is a favorite game. He rolls the ball under the chest, and then I have to go get it. It's like his version of fetch. It's reverse fetch, and I'm not thrilled with it.
Exactly what I was going to say. I was like, he's training you to fetch.
Yes, he has trained me to fetch, and you know what? This is why we have larger brains than dogs. I'm not falling for it.
Are you sure?
Hey.
Not about brain size, but about falling for it.
Yeah. Turns out dogs are really, really good at basically long-term planning and plotting. They're really good at it. Most people don't give dogs credit for how good they are at plotting things. They will plot things out several steps in advance. They're fucking chess players. I told you, it's going to get much more intense. So here's another thing. I'm such a dweeb. I have like sensors lying all over the place. So this is a Nordic semiconductor sensor that's been sitting here on this thing running for, I don't know, the better part of a year. I have this god-awful mess, which is a particle argon sensor that has, oh look, it even tells me that the temperature is 24 degrees C, the humidity is 37.5%, the pressure is 997, the dust is 2,498 pieces per liter. And this has just been sitting over here randomly running for, I don't know, I built it probably last summer, and it's just been sitting here ever since. I'm like, I should probably do something with it. Anyway.
That data that it's collecting, is it being stored somewhere?
Yeah. Oh, I have several time series databases running, collecting all this data from all these sensors and just storing it. I don't know what I'm doing with it, but I'm storing a lot of it. Right? So now we have 2. Yay, but we need 4. So this will only take a minute. Hey, buddy, no, I'm not doing it. We're busy here. We are live. And you...
I'm just standing there talking.
Huh?
Obviously, you can get my toy.
We've discussed this. Haven't we, buddy? We've talked about this. This is what's called a you problem, not a me problem. That's a you problem. You did that. You're looking at me like, but I don't have thumbs. I can't reach. I gotta say, he is one of the funniest dogs I've ever had. He is a regular comedian. At one point when I was working at some labs, we were doing a hands-on lab at Java 1, and we were going to have 100 people in the room, and each one of them got 2 sunspots, and we had to solder headers onto all of those sunspots, and there were 16 solder joints on each header. And so we basically lined up a bunch of soldering irons and made some soldering stations, and a couple of us spent a large number of days soldering, and so I got actually pretty good at doing soldering because I soldered, like, I spent literally 8 hours, 9 hours a day for the better part of a week doing nothing but soldering these small little headers onto sunspots. One of the things I miss about working at Sun was we had a lab there that had a soldering microscope. And I learned to solder under a microscope, which is kind of cool because you think, well, I'm looking at a microscope, and you see surgeons doing this, right? And how can you do that? But as soon as you start looking in the microscope and bring your stuff into the field of view, all of a sudden your brain wraps around, okay, this is the size of the thing. And you can be really, really accurate with soldering very, very small things. That's one of the nice things about this Metcal is it's got exchangeable tips. So you can get really, really, really fine tips on it so that you can do microscopic soldering. So that's all 4 of those. We've now got 4 RJ11 jacks. Yay! What we also need to do is we might need to read the directions on this little. Yeah. So let's come back over here and actually see what we have to do in order to wire this. So as I said, I'm not a hardware engineer. I know fuck all about hardware other than what I've taught myself. And one of the things I taught myself is to do the following. Google is your friend. This is a SparkFun.
Can I get bigger?
Yes, I can embiggen it. Is that better?
Yes.
So, I believe that's the one I have. Nope, that's not the one I have. Let's go look under power chargers, find the one I have. Sunny Buddy MPPT solar charger. This is the Sunny Buddy MPPT charger. That's my Huckleberry right there. And usually, look, documents. There's a schematic. There's Eagle files if you want to actually go have this built yourself. There's a data sheet, and there's a hookup guide. So we look at the hookup guide. Can't do anything without a supporting cast. Pair the Sunny Buddy with these buddies to make it work. A solar panel and a battery. And what do you know? I have a solar panel. I have this big, which one is this? This is, I think, the 9 watt. No, it's the 6 watt. So it's this big 6 watt. And then I have this 6 amp hour lithium ion battery, right? And so here, if you want to learn about how batteries are charged, and I spent way too much of my previous life investigating batteries and learning about this power drop off and all this kind of stuff that I just don't want to read right now. So we're not going to. So here's how we hook it up. Outstanding. Primary barrel jack. That's this because these solar panels come with a barrel jack, and it just, oh yes, that plugs in there, right? And then there's this one that's marked battery. And so I'm going to make a ginormous assumption that the battery plugs in there. But before I actually fully plug it in, I'm going to check this and make sure. Yes. So you see this here? Can you see? Here, let me embiggen that some more. So.
This website has a lot of great resources.
Oh my God! Do they? They're SparkFun and Adafruit are my two favorite websites in the whole wide world because they have all these parts and all these, data sheets and hookup guides and sample code. So, good developers copy, great developers paste. So you can just go in there and say, here's the library to run this thing, and copy it and paste it into your project, and off you go. Everything just works. Well, in theory. So yes, here's our battery. So we plug our battery in over here. And generally, these things only go in one way. It's got this little shark fin on the top of the connector, and it only goes in one way. And so that's plugged in. And if we had sunlight in here, or bright enough light in here, we would probably see an LED light up on this board and tell us that it was generating power, right? So you can add these 3.5 millimeter pitch screw terminals if you want, and you would put those here or here. So here's your battery charge connection, and here's your load connection, right? So the load is going to be towards the device you're wanting to drive. So I would put wires here to drive my device, right? So that is going to have to be, I don't think I didn't buy those connectors, so let me see if I have some here in the pile. It's embarrassing almost. I have these boxes full of stuff. This is a little board that actually has a SIM card in it and connects to the cell network, so you can send data over the cell network. And I'm looking for the right kind of connector to put this thing on so that I can. Is that going to be it? Yes, ma'am. So, this little bugger, it's just a little pigtail. It looks exactly like the plug that I used for the battery. It's just a little pigtail, and what I can do, these ESP32 devices, you'll notice that I am totally doing absolutely phenomenally bad electro-isolation, because I could be full of static electricity and the blue smoke could already be out of these things because I'm just farting around with them. So if you have static electricity on yourself and you touch, electronic components, you can have enough static electricity in you that when you touch the component, it goes poof, and it no longer works.
Oh no!
You have basically shorted it out, right?
And how would you prevent that?
I'm glad you asked. Somewhere I have, you can see how much I use it. It's right here in my I actually have two of them in case I have a solder buddy for the day. It's a wrist strap, right? And what you do is you put this wrist strap on. Yes, and then it's got this little clip. And you can clip it to a grounded object, and now you're grounded and you won't have static electricity built up on you. And my solder mat here actually has grounding corners on it, so I can clip into them. And it is actually, there's a wire going off the back of my solder mat that goes down and screws onto the grounding terminal on the electrical outlet in the wall. Yeah. So I'm completely grounded, right? And what I've actually done is I've connected the grounding wire of this mat to the ground, I have a ground terminal on this cabinet. So actually all I have to do is clip onto the cabinet and I'm grounded, right? And that will keep me from cooking anything in theory. I've still managed to cook things, even being grounded, just because I'm that bad of a hardware engineer. But so here we have our little ESP32 and our little pigtail connector, and it will plug right in there. And so if I solder this pigtail connector to this board right here and plug them together with this battery, this board will power on, 100%. So why don't we go ahead and do that? First thing we do is disconnect all power sources. I used to be quite well known in Sun Labs for connecting components live. which is bad practice. Don't do that. I still do it, but don't do that, kids at home. Don't do that.
I say not as I do.
Right. And I generally now am pretty good about only doing it when I'm connecting things to like one of those ESP 8266 devices that's only a buck and a half. So if it cooks, it's like, meh, throw it away and get another one. Right? It's fine. This is fine. So, my actual wire strippers are out in my electrical bag because I've been doing electrical work at my wife's office on the weekends. So I can cut glass in perfect circles though. I have a tool for that. I have, everybody makes fun of me because I have a tool for everything. And our best friends call and say, hey, do you have a tool to do you have a way to do this? And I'm like, yeah, I got one of those. Be right over. And they're like, of course you do, right? Somebody asked me one time, do you have a 20-foot extension ladder I can borrow? And I was like, actually, I've got an extra. You can have it. And they're like, who has an extra? I'm like, yeah, well, whatever.
Do you want it or not?
Right. It's free. You gonna look a gift horse in the mouth? So, there's the red wire stripped. This is easier with my actual wire strippers than doing it with a pair of clips, but I don't feel like going out in the garage and getting them because that's like, I don't know, 20 feet. It's 20 feet away, and that's too far. I don't have time for that. Right. That would send the wrong message to Bruno.
Exactly.
Okay, so we have this board, and here's the load, and we have plus and minus. So we put plus in the plus hole. And the minus, are you really going to give me this kind of grief today? So, Rain, whenever you're ready to like work on your project, we can do this together.
My little water filter and auto.
Yeah. We can get that working.
I would love to follow the instructions. It came with a little Arduino.
Now, here's a little trick that I use to keep the wires. Yeah, it came with a little Arduino board.
Yeah, a CH340B driver is required, which I did. I think I installed it on this laptop.
Yeah.
That I'm using.
What kind of, what does it say on the little shielding? See the little silver shielding? What does it say on there?
AZ delivery.
Really? It should be on here. See? Mine says Espressif ESP 32 Vroom. No, on the other side. Yeah, see that big shield, that big silver shield on it?
This bit?
Yeah, that bit. What does that say? That looks like an 8266.
This is where I take off my glasses.
Yeah.
To show my model ESP B.
Yep, it's an 8266.
Why does it have to be super tiny? 8266.
Yep.
MOD 12F? Model 12F?
Yep. 8266s, everybody uses them in these kinds of kits because, again, they are super cheap. If you're buying the bare module, not on a breakout board, the module is like 50 cents. So what I've done here is I've stuck the wires through the hole, right? And then what I do is I bend the wires back nice and flat so that I can take this nice little clamp and clamp it on there, and it holds the wires in the hole. That's not in the right place. There, is that better?
Yep.
Okay, so now all I have to do is turn this over like that, and drop a little bit of solder in there. Another little tip for you home folks is get yourself one of these. This is what's called a desoldering tool.
What does it do? I mean, it designs unsolder.
Yes, it unsolders things. So here, I'll show you what it does. So this board's all soldered up, right?
Yeah.
And actually, this side only the 3 volt and the reset pin are actually soldered. The ones in the middle are not. So I can take this little thing and I push down the plunger, and it's got a little button on the side. And I can take my soldering iron and I can put my soldering iron right here on this solder, and it starts to melt. And I put this, hold on, I got to get it so it's not running away from me. And I put this right over the top of it, and I go and I push the button, and the plunger pops out, and you heard a little suction noise maybe, and now you can see that there's no more solder in that hole.
That was so cool. It's like a baby vacuum.
It is. It just goes, and it a little puff of air, and with the solder being very hot and liquid, it sucks that little bit of solder back up in. And so if I want to, I can take this little bit of solder out, and then I can take this header off. So if I have soldered something wrong and I need to undo what I did, and home taught hardware engineer, solder something wrong every day, it's really, really handy to be able to undo that. So now let's come back over here. And I have this little device here, right? And it's running, and I can tell it's running because this little glowy thing on my CO2 is blinking and telling me that it's on. And if I unplug it, it's still running because it's got a battery. But if we take this battery off, it's now dead because it's got no power, and that's how the world works, right? So we take this and we plug our battery into the battery terminal. And this is a big honking battery. This will last for a very long time. And then we take our newly soldered little pigtail and we plug it into, let's just make sure that the polarity is the same. And yes, it is. So I unplugged this battery, right? And it's got a red and a black wire, and I'm lining up the 2 plugs, and yeah, the red's on the same side and the black's on the same side, so hopefully we will not see a puff of blue smoke and everything will stop working. And we will plug this in here. It's blinking. It's working. So now we know that this little solar charging board will drive an ESP32 with a CO2 sensor, so it should drive everything else. And we can put it on our solar charger And we could take this outside and we could put it out in the sun and it would run forever, or at least until it rained, because none of this is protected and it would all get all fried in the first rainstorm. Which is why I have that thing over there, which is a 3D printer so that I can print enclosures. So that little CO2 sensor that I said lived on my front porch, I built this little box for it. So it's got louvered holes on both sides that go up. So air can go up, but water typically doesn't make U-turns, right? And then it's got I designed this little slide. So it slides shut so that it doesn't leak water at the top either. And I can put the USB or the cable through the bottom, and it can sit on my front porch, and it can continuously monitor CO2, and it won't get wet. So at some point, I will actually have to design a box for this with the solar charger and all that, so that I can put it all in a box outside, and it'll all run off the solar, and it won't get wet, and it can sit out there on my weather station forever and be done. So how was that?
That was awesome. We got started.
Yep.
We can do this every Friday at this time-ish if you're keen, or every other Friday or something.
I would love that. I would love that. Let's do that. So, yeah, next Friday's good. Friday after that, I'm actually going to be, starting that week, I'll be down in Florida for a month. But my friend in Florida is going to be shocked because I'm bringing all this shit with me. Because I got to work on this project. And so I'm bringing my 3D printer and my soldering iron and my desolderer and all of that with me so that I can work on this project from down there. And I'll bring both the cameras and I'll bring everything, my solder mat and everything so I can set up and we can keep going. And maybe what we do next, I will finish all the hardware hookup for this bit right here for the outdoor station. And next Friday we can write the code to actually make this thing collect all our data and send it someplace. Would that be a good, does that sound like a good second session?
Yeah, that sounds awesome.
And we can do those sort of, we can alternate, this is a hardware week, this is a software week.
Yeah, I love it.
Yay, super cool. This is fun. I don't care if anybody's watching. We're having a good time.
Okay. Well, you gotta run to my next thing.
Yep, samesies.
As always.
This was super fun. Thanks for being here.
Yeah, happy to be here.
Talk to you soon.
See you next Friday.
Yeah. Bye.